Ariel Munitz, Tel Aviv University. Eosinophils, the underdog of the tumor microenvironment.
Okay, good morning. I would like to talk to you today about eosinophils and how they interact in the tumor microenvironment. So to those of you who don't remember, eosinophils are bone marrow-derived granulocytes, immune cells, which circulate in very low levels in the peripheral blood. However, they substantially reside in mucosal areas. This is nicely demonstrated here in this slide, where you can see a lining of eosinophils in the muscularis mucosa and the lamina propria of a colon of a healthy individual. Eosinophils have been dramatically and substantially studied in context of type 2 immune responses in diseases such as asthma and allergy. For example, in asthma, eosinophils have major effector roles, and the FDA has recently approved 2 targeted therapies against eosinophils. However, one area which eosinophils have been considerably overlooked is the area of cancer. And this is highly surprising due to the fact that eosinophils have been known to infiltrate various tumors for more than 120 years ago. So one of the objectives that we have in our lab is to define the role of eosinophils in colorectal cancer. And the reason we focus on colorectal cancer is due to the fact that the GI is the largest homeostatic niche for eosinophils. So do eosinophils accumulate in experimental colorectal cancer? And the answer is yes. Taking advantage of immunohistochemistry, staining for eosinophil granule proteins, you can see accumulation of eosinophils in inflammatory models, in genetic models. Moreover, eosinophils which accumulate degranulate in the tissue, meaning that they are hyperactivated and can actually release their content. So what do eosinophils do in this tumor microenvironment? How do they affect tumor growth? To cut a long story short, eosinophils are anti-tumorigenic in cancer. They can actually kill tumor cells. You can see this by taking advantage of eosinophil deficient mice, here in red, where you can see that tumor-induced morbidity is significantly increased, and this is associated with significantly increased tumor load. This is not shown only in this inflammatory model, but also in the genetic model, where you can see substantially increased death, which is associated with increased tumor burden. So what can we do with that? With the knowledge that eosinophils can kill colorectal cancer cells also in vitro. We know that suppression of immune checkpoints on T cells, targeting inhibitory receptors on T cells, is a promising approach in immune oncology today. Our laboratory has unique expertise in inhibitory receptors on eosinophils. So can we target these immune receptors in eosinophils as a second or even third generation of immune therapy? This is actually our goal. Our objective is to unleash these anti-tumorigenic activities of eosinophils in specific cancers where eosinophils migrate into. And I would love to discuss with you and maybe share a beer. Thank you.